Hello everyone. Today we are going to be discussing about a very interesting concept as far as chemistry is concerned, and that is isotopes and isobars. This topic, as simple as it sounds or as simple as it looks, gets students confused a lot of time. But the truth of the matter is that whether you get confused or not, or whether you know it or not, these questions from this topic will always come out whether you're preparing for your JAMB UTME, for your YA post UTME, or even your class internal examination. But in this video, I will make sure I simplify this topic down to the barest minimum. That means we will be talking about everything based on isotopes, and we will also be discussing everything on isobars. You will get to know what isotope means, and you will get to also know what isobar means. If you're coming across my channel for the first time, my name is Basi Ejogba. I'm a student in the University of Calabar studying medical laboratory science, and in my channel I help students level up the academic game. I also share full tips on the channel focusing on personal development. So if you love content like this, please don't forget to hit on the red subscribe button so you can continue getting updates anytime I drop videos like this, and so that you can help me grow. And just like you have seen here on the board, we are going to be talking about isotopes versus isobars. Let's start with the first one, which is isotopes. What is isotope, or what are isotopes? Right, this topic is very essential. This particular concept is very essential, and this concept here also has solving attached to it. But I don't think I am going to solve anything here. I'm going to solve any problem here. But I believe I've made a video when I was talking about I think I'm here to drop that particular video where I discuss about this isotopy. Right, so what is isotope? We all know that isotope is a phenomenon. Right, it's a phenomenon whereby an element has the same occurrence of an element, right, having the same atomic number, but different mass number. Right, so we are going to say isotopes. We are going to say isotopes have the same it's an element. Right, it's a phenomenon. It's a phenomenon whereby an element is a phenomenon whereby an element has the same atomic number, has the same atomic number, but different mass number. The same atomic number, but different mass number. They have the same atomic number, but different mass number. Now this can be seen, for example, we have our chlorine for example. Is it chlorine? Should I use chlorine, or should I use, let me use carbon? We have our chlorine. Yes, we have our chlorine. We have our chlorine to be chlorine 17, right, and chlorine 35, and we also have our chlorine 17 and chlorine 37. We also have our carbon 12, and we have our carbon. Yes, we have our carbon, which is weak, and we have our carbon 12, and we have our carbon, and we have our carbon 14. When you see this concept, this is what is known as isotopy, whereby this particular element has the same atomic number, but different mass number. That is what isotopy is all about. That means what we are going to be having here is something represented as this. We assume S is our element, and our Z, right? We have our Z as atomic number, and we have our A as the mass number. So this is the elements. So this is our central element. This is the atomic number. So we say AN, and we have our A right? So that is just how it is when it comes to the concept of isotopy. Right? Let's talk about isobars. What are isobars? So isobars is just like the should I say, it looks like isotopy, and that is where a lot of people used to get it wrong, right? Because when some people hear iso and also hearing isobars, isotopes, they feel the same thing, right? But isobars are elements that have different they have the same they have the same mass number, but different atomic number. So we say isobars are elements, right? Are elements. Take note, I am going to be saying something very interesting. I say isobars are elements, right, having the same mass number. Elements are elements having the same, they have the same mass number. They have the same mass number, but different atomic number. Please take note, but different what atomic what number, right? Please take note. Now when it comes to the concept of what the what isobars, right? We have something like, we have an example here. We say what carbon, we have our carbon 40, we have our calcium, right? We have our calcium to have a mass number of 40, and we have our what argon, right? We have our argon also to have a mass number of what 40, right? What is happening here is something that is self-explanatory. When it comes to the isotopes, remember we said we have our what chlorine, right, to be 17 and 35, and we have our chlorine to be what 17 and 37. You find out that for the isotopes, they have the same what atomic what number, and it is the same what element, right? They have the same atomic number and it is the same what element. But for the isobars is that they are different elements, but they are having the same what mass number. It is because of these variations, or it's because of these differences, that led us to move or to transition from the old periodic law, which was propounded by what Dmitri Mendeleev, which group element based on their periodic what, based on their atomic mass, to their what atomic what number. It was because of these behaviors that made us to fall onto what atomic what number, knowing fully well that the atomic number influences the chemical properties of what an element and not the what mass what number, right? Because the calcium having the same mass number as argon, right, they don't behave the same what, they don't have the same what properties, or they don't behave the same what way, right? So that is why we have to move on from mass number, rather we now focus using their what atomic what number, right? So let's talk about the features, the key feature differences between the isotopes and the what isobars, and from here also we will get to solve a particular question that we can get, that I was able to get from the JAMB pass question, right? So that is just it. So we are going to be having the key differences, we are going to be having the features of the key feature differences, right? So we are going to say our feature, right? When you see this feature, you'll be able to know which one is what isotope, and able to know which one is what isobar. So we have feature, we have here our isotopes, and we also have here our what isobars. We have our isotope and we have our what isobars. So the first feature we have here is what atomic number. So we say our atomic what number, which is represented as what letter what Z. For the atomic number, when it comes to the isotopes, they have the same what atomic what number. So we say they have the same what atomic what number, but here for the isobars they have what different what atomic what number. So they have different what atomic what number. Then we have here atomic mass, or the mass number, which is represented as what letter what A, right? For the mass number, they have what different mass number, but for the isobars, they have the same what mass what number. It is very, very important you understand all of this. Then for the elements, right, we know that the isotopes have the same what elements, so we say same what elements, but for the isobars they have what different what element, right? Is different what element, right? Then for their chemical properties, their chemical what properties, right? Their chemical what properties, right? Isotopes have the same what chemical what properties, and the isobars have what different what chemical what properties, right? So their chemical properties is what different, because the atomic number determines the what chemical properties of what an element, right, and not just the mass number. While the isobars focuses on the what mass number, the isotopes focuses on the what atomic what number. We say that when it comes to the isotope, is the same element but different what mass number, but the same what atomic what number. But when it comes to the isobars, like the example I've given, they have what different elements, same what mass number, but different what atomic number. Hence their properties, or their chemical properties, is going to be very what distinguishable, and going to be very what different, right? So we have a particular example here. See, particular question we have here on the board. Please screenshot this and make sure you copy it down, right? We have a particular question. So we have a particular question here, and the question goes is, which of the following pair of species are isotopes? So you say example, which of the following pair, which of the following pair, which of the following what pairs of what, which of the following pair of what species right, are what? Isotopes. Which of the following pair of what species are what? Isotopes. Right, we have A, we have 23 disodium and magnesium. We have 23 sodium and magnesium or 24. We have our B here to be 16 oxygen and what? 18 oxygen. We have our C here to be 14 nitrogen and what? 14 what? Carbon. And we have our D to be 40 calcium and what? 40 what? Potassium. Now looking at this on the board, what we are looking for is which of the following species are what? Isotopes. And remember I said the isotopes, they have the same what? Atomic what? Number, right? They have the same atomic number but different what? Mass what? Number. And for the isotopes, they must all be the same what? Element. Right? So what we are looking at here right now, so which of the following pair of species are what? Isotopes. So we have A here, 23, mass number 23 of sodium and what? Mass number 24 of magnesium. This is not the what? Answer, right? And this is not an isotope. This is not also what? An isobar, right? So we have B, we have atomic mass of what? Mass number what? 16 for oxygen and mass number of what? 18 for what? Oxygen. So the correct answer here is going to be what? B, right? But let's also talk about the C and the what? D. So we have 14 here. We have our 14, which is mass number 14 of nitrogen and mass number 14 of what? Carbon. This is what? Wrong. This is neither an isobar or this is neither what? An isotope. Right? For the D, we have 40 calcium, 40, that is mass number 40 for calcium and mass number 40 for potassium. This is what? An isobar. This is what? An isobar, and this is what? And what? Isotopes. Right? So this is very, very important, and it is necessary that you understand the difference between what? An isotopes and what? An isobar. I believe you really enjoy this simplification of this term. And if you want to join our private classes where we have our exclusive tutorials, you get access to materials and you also get timely responses from our teachers. In case you need any clarification, drop it in the comment section, request for my number, or just indicate interest in the comment section. I will share my WhatsApp number with you. Chat me up on WhatsApp and you'll get to be added to our WhatsApp group. And when you join our WhatsApp group, you will, like I always tell people, when you join our WhatsApp group, scoring 300 plus is going to be just like a walk in the park, because you will be well equipped to face your JAMB UTME. If you love this video and you wish to continue getting videos like this, please don't forget to hit on the red subscribe button so you can continue getting videos like this, and also share this video to your friends so they can come here and get value, and in turn I'll feel motivated to continue dropping videos like this. Until I see you in my next video, always remember that you're wonderful, always remember that you're unique, and always remember that you're a pace setter. I really love you. Thank you.